Hi, I'm V from Packard Micro, and I'm going to show you how to perform probe planarization on either even or uneven surfaces in a few simple steps. Remember, it's essential to have good contacts on both probe tips for accurate, repeatable RF measurements. The first thing you need to do is decide whether you're going to probe on even surfaces such as a bare printed circuit board or on uneven surfaces such as solder bumps. We recommend you use the Mylar tape approach whenever possible because it's the easiest and most efficient way. However, when you encounter probing on uneven surfaces such as solder bumps or when there is no room for affixing a Mylar tape, we recommend you use the color marker approach. In addition to Mylar tape, the TCS60 substrate, and a fine tip Sharpie, a good microscope with greater than 90 times magnification helps you see the probe tips clearly. Remember that you should not perform probing tasks if you cannot see the probe tips in the DUT well, because you'll increase the chance of breaking the probe tips. Here, we're going to show you how to use Mylar tape to probe test pads on even surfaces, such as a bare printed circuit board. The probe tip planarization can be done quickly by observing the indentation caused by the probe tip on a piece of Mylar tape. This approach is twice as fast to the conventional approach of observing the probe tip skid marks on the test pads. Start by affixing the Mylar tape to the circuit board near the test pads or other flat surface, such as the back of the plastic cover of the TCS60 substrate container. Also, make sure the test probes are securely mounted on a TP300 or TP60 probe positioner. In this demonstration, we're going to show you how to level the probe tips by affixing Mylar tape to the board under the test point. You should see an indentation mark while the probe tip touches down on the Mylar tape. In this case, the signal pin touches the surface first, so you'll need to adjust the probe leveling. However, if you over-adjust the probe leveling, you'll see the ground pin touch down first. Lastly, if you see the indentation marks of both the signal and ground tips occur almost simultaneously, you have now leveled the probe tips correctly and can perform accurate RF measurement. Now proceed to move the tips to the test pad for probing. You can also use the TCS60 substrate to perform the probe tip planarization by observing the probe scratch marks on the substrate. If you only see one tip mark, this means that only one probe tip is touching down, so planarization adjustment is needed. The two probe tips are properly leveled when you see two tip marks on the substrate while lowering down the probe with a TP60 or TP300 probe positioner. You can also use the Smith's chart on the VNA to verify both tips are making good electrical contacts. Sometimes you may need to probe on solder bumps that are typically on uneven surfaces. In this case, the Mylar approach no longer works, so we need to go back to the conventional way of observing the probe tip skid marks. Since it is difficult to see the skid marks on the solder bumps, color the bumps with a fine tip Sharpie to make the skid marks more visible. Keep in mind that if you only see one tip mark, this means that only one probe tip is touching down. Therefore, planarization adjustment is needed. In this case, the right ground tip touches down first. The two probe tips are properly leveled when you see two tip marks on the solder bumps when lowering the probe with a TP60 or TP300 probe positioner. After you confirm that both tips have made contact using the probe skid marks, clean up the solder bumps with industrial alcohol after probing. Thank you for watching. Now that you've seen how easy it is to use the Mylar tape and color marker approach to perform probe tip planarization on even and uneven surfaces, our rugged probes can help make further accurate, repeatable gigahertz RF measurements. Please contact us if we can offer any assistance, and check out our YouTube page for other tutorials.